Okay, let's unpack this. You know that feeling when you blink and suddenly AI can do, like, 10 new incredible things?
Yeah, it's almost overwhelming sometimes.
It's like trying to drink from a fire hose some days. But that's why you're here.
Right.
Welcome to the Deep Dive. We take all the groundbreaking news and dense research in AI and we boil it down.
To the really fascinating stuff.
Exactly. The insights that make you go, aha.
Yeah.
And we try to tailor it directly to you.
And today, we're laser focused on the latest wave of AI advancements coming out of Google. We've sifted through their official announcements on YouTube. And also a really comprehensive analysis that helps connect all the dots.
Yeah, we've done the heavy lifting, watched the keynotes, dug through the reports. Our mission today is pretty simple. Understand what these core AI breakthroughs from Google really mean for you.
How might they actually change things?
Yeah, how they might change the way you experience everything from, I don't know, exploring new places to just kicking back and enjoying some music. We want to uncover the driving forces behind Google's AI vision.
And what's particularly interesting, I think, is that these aren't just like isolated improvements. Our sources point to 5 key areas where Google is making significant progress.
Okay.
And they're all kind of building on each other.
Think of it as a sneak peek into the near future, maybe. We're talking about hyper-personalized AR experiences.
Right.
AI-powered dynamic storytelling in games.
That sounds fun.
Seamless real-world object-to-digital asset creation, proactive AI learning assistance, and emotionally intelligent AI music generation.
Quite a list.
It is. So buckle up, because this is where it gets really interesting. Let's start with hyper-personalized AR experiences. Forget those clunky filters. It sounds like AR on a whole different level, doesn't it?
Absolutely. The focus has shifted.
Yeah.
It's now AR that understands your context and caters to you specifically.
Okay.
And several technologies are converging to make this possible. Multimodal AI is really the foundation.
Multimodal, so multiple types of input.
Exactly. Think of it as AI that can understand not just text, but images, videos, audio, even data from sensors. Kind of like how you take in information through sight, sound, touch.
Right, processing it all together.
Precisely. Models like Gemini 1.5 and GPT-4 Turbo are examples of this capability, as our analysis highlights.
Okay, so the AI is taking in all this different kinds of information, but how does that become my personalized AR experience?
Well, that's where semantic scene understanding comes in.
Semantic scene understanding.
Okay, imagine your AR glasses being able to tell the difference between the sidewalk in a building or the sky in a tree, just like you do.
Ah, okay, so it understands the environment.
Exactly. This technology allows digital elements to interact with your real surroundings in a much more, well, realistic way. Google's Scene Semantics API for outdoor environments is a real-world example of this, helping AR systems make sense of what's around you.
So if an AR app wants to show you directions, it won't just slap an arrow in your field of vision. It'll understand you're on a sidewalk and place the arrow, like, logically on the path ahead.
Got it. Now, Neural Radiance Field's NERF. That sounds like something out of Star Trek.
It does sound futuristic, but the core idea is about creating incredibly realistic 3D representations.
How so?
Well, think of taking a whole bunch of photos of something, like from every single angle, and then AI uses those photos to build a complete high-fidelity 3D model. That's essentially what NERF does.
Wow.
It allows digital objects to blend really seamlessly with the real world. There are even tools now, like Luma AI's plugins for NVIDIA NERF, making this powerful tech more accessible.
Okay, so NERF creates these super realistic digital objects and environments. Now, how does Google get all this onto our devices, like phones or glasses, and make it interactive in real time? That sounds computationally heavy.
It is, but that's where Google AirCore and Android XR come into play. These are the platforms, the groundwork, really, for AR on Android phones and, crucially, on smart glasses. And powered by AI, like Gemini.
Exactly. Powered by Gemini AI. Our analysis points out how this enables real-time, context-aware help. Imagine having information pop up exactly when and where you need it.
Right, when you need it.
Controlled by just looking, or maybe gesturing or speaking, and even with real-time translation happening right before your eyes.
Hands-free real-time translation appearing in your vision? That's seriously impressive. And the last piece of this hyper-personalization puzzle is, well, me, right? My data, my preferences.
Precisely. The AI algorithms can analyze your data, things like your search history, maybe preferences you've explicitly stated, to tailor those AR interactions even further.
So it's not just knowing I'm looking at a museum.
Right.
It's knowing I'm particularly interested in its Egyptian exhibit because I searched for that last week.
Exactly that kind of thing.
Okay, so we've got the tech stack, basically. Now, where might we actually see this in action? What are the applications?
Our analysis details some really exciting possibilities.
Hmm.
For tourism, imagine walking through, say, ancient Rome and seeing digital reconstructions overlaid on the ruins.
Wow.
Or having an AI virtual guide pop up and point out interesting details based on your interests. Google Lens already gives us a small glimpse of this today.
That's like stepping back in time without leaving the present. Amazing. What about other areas of our lives?
Well, in education, AR could create these immersive 3D learning environments that adapt to how you learn best.
Personalized lessons.
Yeah. And for shopping and home design, you could visualize furniture in your living room before you buy it, or easily create 3D models of real objects for design projects.
I can see that being useful.
And think about communication. Real-time translation via AR glasses could break down barriers. Plus, more realistic 3D video calls, like Google Beam or Project Starline, could make remote interactions feel much more personal.
Like you're actually in the room together.
Almost. And for everyday tasks, think about hands-free navigation or proactive help, like reminders about appointments or help drafting a quick message. All context-aware.
So it's really about making technology more intuitive, more helpful, and just seamlessly integrated into our lives.
Okay, but there have to be challenges, right? Ethical stuff.
Oh, absolutely. Big ones. Data privacy is huge. What data are these systems collecting? Location, visuals, maybe even biometric data.
Right, and consent. How do you manage that?
Exactly. Then there's surveillance and potential misuse, bias baked into the algorithms, the sheer computational demand, and latency issues.
Lag could really ruin the experience.
Definitely. And even over-personalization, where it feels intrusive or you get stuck in a filter bubble. Trust is a major factor, too. It's that classic privacy utility paradox. How much privacy are you willing to trade for convenience?
A tough balance. Okay, let's shift gears. Let's dive into something that sounds like pure fun. AI-powered dynamic storytelling in games. Forget those predictable storylines. AI is promising games that truly react to what you do. Exactly. Our sources highlight this shift away from fixed narratives towards stories that evolve based on your choices, your play style, maybe even your emotional responses.
Wow. Okay, how?
At the heart of this is generative AI, large language models and natural language processing.
Like the tech behind ChatGPT.
Similar underlying principles, yes. Applied to games, it can adapt environments, create real-time dialogue with characters, even generate new quests and storylines on the fly. Google's talking about models like Gemma 3 and Gemini 2.5 being used here.
So the game world and the story aren't set in stone anymore. They can actually change as you play. That sounds like it would make games incredibly replayable.
Totally. And what other cool tech is involved? Well, reinforcement learning, or RL.
Okay, RL, how does that fit in?
RL plays a big role in making games more engaging and helping you develop your skills. Our analysis mentions how AI bots using RL can train in games like Rocket League at incredible speeds.
So they become super skilled opponents.
Or teammates, yeah. Think of it like an AI player that learns from its mistakes and gets better over time, constantly adapting to your playstyle.
Okay, so AI can make the game smarter and more challenging. Now, you mentioned adapting to player emotions. That sounds both amazing and maybe a little intense.
It does, yeah. That's where effective computing comes in. Imagine a game that can sense if you're getting frustrated or really excited.
By watching me.
Potentially by analyzing facial expressions via a webcam, or maybe even physiological responses through wearable devices like smartbands. There's work being done, like OvaMind's integration, allowing games to potentially adjust the difficulty or the story based on how you're actually feeling.
So if the game detects I'm getting stressed, it might, throw me an easier challenge, or if I'm really enjoying a certain part, it might expand on that. That's fascinating.
It really is. And then there's procedural content generation, or PCG.
Right, PCG, I've heard of that. Creating content automatically.
Exactly.
Yeah.
PCG allows the game to dynamically create parts of the game world. Landscapes, buildings, dungeons, even entire quests. The game No Man's Sky is probably the most famous example, using PCG to create a massive, largely unique universe for each player.
So instead of human developers having to handcraft every single rock and tree,
Right.
AI can step in and generate a lot of that content. That could free up developers to focus on other things, right?
Sure.
More creative aspects.
That's the idea. Now, how does all this AI power translate into the actual gaming experience for you, the player?
Yeah, what does it feel like?
Our analysis highlights several cool applications. Adaptive narratives, for one. The story can branch out in countless ways based on your choices, leading to truly unique playthroughs.
So everyone's game is different.
Potentially, yeah. Games like AI Dungeon are built entirely around this. Even
Yeah.
older games like Fallout, New Vegas used elements of this. Then you have dynamic quests and scenarios generated on the fly, fitting right into the game world, and intelligent NPCs.
Non-player characters.
Right. Imagine characters that have more complex behaviors, remember your past interactions, and hold conversations that feel much more natural and responsive. Google showed a sample game, Gemma Journey, where NPCs have bespoke dialogue generated by AI.
That would make game worlds feel so much more alive.
Definitely. And it's not just about entertainment, is it? Our analysis also touches on potential uses in therapy and education.
How so?
Well, therapeutic games could use AI to adjust the level of challenge in ways that might help individuals with conditions like ADHD or brain injuries. And effective computing could adapt gameplay based on a user's emotional state for mental wellness.
Interesting. And education.
Educational games, like Prodigy Math or Duolingo Kids, already use AI to adapt difficulty in content based on a child's performance. It creates a more personalized learning journey.
So the future of gaming looks incredibly dynamic. Unprecedented replayability, deeper immersion, maybe entirely new genres we haven't even imagined yet, and it could also speed up game development itself.
Exactly. The possibilities are vast and really exciting. But again, challenges exist.
Like what? Keeping the story coherent.
That's a big one.
Hmm.
Narrative coherence when things are being generated on the fly. Also, the computational costs can be high, and predicting player behavior is always tricky.
And the ethical side, especially with the emotion stuff.
Yeah, the potential for psychological manipulation or addiction is a concern. Bias in generated content is another. It's a shift from predictable scripts to emergent realities, and that requires careful thought about ethical AI use.
Definitely something to keep an eye on. Okay, let's move on to something that feels almost like magic. Seamless real-world object to digital asset creation. Imagine pointing your phone at, say, your coffee mug and instantly getting a perfect 3D model of it.
That's becoming much more of a reality thanks to AI. The core technologies here involve generative AI, again, specifically text to 3D and image to 3D models.
So you can create 3D from text or pictures.
Right. You could potentially describe an object or show the AI a few pictures, and it generates a 3D model you can use, maybe an AR or a design program. Companies like 3DFI.ai and Meshi.ai are already offering tools for this.
So I could just describe a specific type of chair to my phone, and an AI could generate a 3D model of it that I could then place virtually in my room. That's incredible.
That's the goal. And just like with the AR experiences we talked about, 3D reconstruction using NERF is also a key part of this for capturing real objects.
Right, NERF again, for high-fidelity capture.
Absolutely. NERF allows for capturing the precise geometry and appearance of real-world objects with astonishing detail. Luma AI's Video to 3D API is a great example. You can create a detailed 3D model just by taking a short video of an object with your phone.
Okay, so NERF helps us capture reality in 3D, and generative AI helps us create new digital objects from scratch or from images. But how do we then make these digital objects actually useful, especially for animation or games?
That's where a couple more pieces come in. Neural rendering helps improve the performance and visual quality of these 3D models.
Making them look better and run faster.
Essentially, yes, by using neural networks in the rendering pipeline itself. And then, one of the really tricky, time-consuming parts of working with 3D models has always been rigging and animation.
Right, giving it a skeleton so it can move, that takes ages.
Exactly. But now, automatic rigging and animation tools, powered by AI, are making this much simpler. Tools from companies like Sloyd.ai and Meshi.ai can automate creating that underlying skeleton and setting up basic animations, especially for standard things like humanoids or animals.
Wow.
Google even has a patent on tech that aims to generate and animate rigged 3D models directly from simple 2D images.
So you could potentially take a picture of a character you drew, and AI could not only create a 3D model, but also set it up so it can be easily animated for a game or a film. That's a massive time saver for creators.
Huge. So what are some of the main areas where we'll see this tech used?
Yeah, applications.
Our analysis details several key ones. Gaming asset creation, obviously generating personalized in-game items, quickly creating detailed models and textures.
Makes sense.
E-commerce visualization, letting you see realistic 3D models of products, like that chair, in your own home before buying.
Very useful.
Industrial design and manufacturing, converting physical prototypes into digital 3D models, for testing, simulation, creating those digital twins of real-world factories or products.
Digital twins, right?
Cultural heritage preservation, using it to document, digitally restore, and present historical sites and artifacts in incredible detail for virtual museums or research.
That's a great use case.
And virtual production in filmmaking and game development, streamlining the creation of all the 3D assets needed, saving significant time and money.
The potential here seems enormous. It feels like it could really democratize 3D content creation, speed up digital twin development, enhance AR and VR experiences, and just slash production costs and time.
Exactly. It's poised to transform how we create and interact with digital 3D content. But again, challenges remain.
Let me guess, accuracy.ip.
You got it. Ensuring the accuracy and quality of the generated models is key. Real-time performance is still a hurdle for complex scenes. And then, intellectual property and ownership, who owns the AI-generated model.
Tricky.
And the potential for misuse, like creating deepfakes or counterfeit digital objects, is a serious concern, along with data security for the inputs used. It's like the industrialization of 3D content creation. But it brings up new questions about digital authenticity.
Lots to think about there. Okay, next up, something that sounds incredibly helpful, proactive AI learning assistance integrated right into your laptop. This goes way beyond just asking a search engine a question, right? This sounds more like an active partner.
Precisely. The focus is really shifting from reactive AI, you ask. It answers to proactive, context-aware AI assistance for learning and productivity.
Okay, proactive, how does that work?
Core to this are AI agents. Think of them as autonomous little AI helpers.
Agents, like spies.
Not quite. More like digital butlers or assistants that can perceive what you're doing, reason about it, and act on your behalf. Google's Agent Space is a platform designed specifically for building and deploying these kinds of agents at scale.
Okay, so these agents are like having a super smart assistant quietly working in the background. How do they know when and how to be proactive without being annoying?
That's the key, isn't it? Through context-aware AI, these systems analyze what you're currently working on. Maybe the code you're writing, the document you're editing, the emails you're reading to understand the context.
So it sees I'm stuck on a specific function.
Potentially, yes. And based on that context, it can offer relevant suggestions, maybe links to documentation, example code snippets, or even anticipate the next step you might want to take. Google has patents related to context-aware notifications, showing they're serious about this.
So if I'm struggling with a particular piece of code, my AI assistant might proactively pop up a little window saying, hey, looks like you're working with APIs, here's the relevant documentation and a common solution pattern.
Exactly that kind of interaction. And it relies heavily on natural language understanding and generation, so you can interact with it naturally, maybe even just talk to it.
Okay. And how does the learning part fit in specifically?
That involves intelligent tutoring systems, ITS, and adaptive learning principles. The AI isn't just giving you info, it's acting like a personalized tutor.
Like a tutor?
Yeah, providing support that adapts to your individual learning style, your pace, your specific knowledge gaps. Carnegie Learning's Mathia is an existing example in math education, and Google's LearnLM, part of Gemini 2.5, is explicitly designed to function as an AI tutor, integrated into their tools.
So it's like having a personalized tutor built right into my computer, watching over my shoulder, but in a helpful way. And the AI can even figure out where I'm getting stuck without me asking.
Yes, potentially through what's called student modeling and learning gap inference. The AI can analyze your performance on practice exercises, quizzes, maybe even your written explanations, to pinpoint areas where you're struggling and tailor its help.
That sounds incredibly powerful. What are some of the real-world ways we might see this kind of technology being used?
Our analysis outlines several key areas. Personalized learning paths are a big one. The AI analyzes your current knowledge and goals to customize learning materials just for you.
Tailored curriculum.
Right. Real-time feedback and support, like having a conversational tutor available 24/7 that can spot misunderstandings and offer concise guidance proactively.
Instant help.
Automated assessments and practice exercises. AI generates quizzes tailored to your weak spots, adjusting the difficulty as you improve. Gemini can apparently already generate quizzes on topics.
Useful for studying.
Definitely. And beyond formal education, think about professional training and employee onboarding. AI could automate parts of onboarding, provide personalized training courses, or act as a chatbot answering new hires' questions.
Speeding up, getting new people up to speed.
Exactly. And even career counseling AI, analyzing your skills, interests, and job market trends to offer personalized guidance on career paths or skills development.
Wow. The potential impact on education, productivity, lifelong learning, it sounds huge, making learning much more accessible and effective for everyone.
Absolutely. It really has the potential to revolutionize how we learn and work throughout our lives. But, as always,
Challenges and ethics, let me guess. Privacy, bias.
top of the list, privacy of all that personal learning data is a major concern. Bias in the AI's recommendations or assessments is another risk. Is it guiding everyone down the same path?
Good point.
There's also the risk of over-assistance or cognitive overload. Does the AI help too much, preventing you from thinking critically? Or does it just overwhelm you with suggestions?
Yeah, becoming a crutch.
Right. And could it lead to over-reliance and a degradation of human interaction, like talking to teachers or peers? Plus, accountability, who's responsible if the AI gives bad advice or misses a key learning gap? Transparency is crucial.
It's that shift from reactive tools to proactive cognitive augmentation, as the analysis calls it. It walks a fine ethical tightrope regarding data and influence.
Very well put.
Okay, finally, let's explore something that really blurs the lines between technology and creativity. Emotionally intelligent AI music generation. This isn't just about computers spitting out random tunes, right? It's about AI understanding and creating music based on emotions.
Precisely. The goal is to move beyond just algorithmic composition towards AI that genuinely understands, responds to, and maybe even evokes human emotions through music.
That sounds ambitious. What tech makes that possible?
Well, it starts with generative AI models, of course, specifically trained on vast amounts of music. Examples include Google DeepMind's Music AI Sandbox, OpenAI's MuseNet, and Google's own Music LM. These can generate novel musical pieces.
Okay, so AI can already compose music. What makes it emotionally intelligent? Where does the emotion part come in?
That comes from effective computing, the field of AI that deals with recognizing, interpreting, and even simulating human emotions.
So the AI can tell if a piece of music sounds happy or sad.
It's trying to get there, yes, and potentially go further. It might analyze facial expressions, voice intonation, maybe even biometric data like heart rate or skin response to understand your emotional state, often using models like the Valence Arousal Dominance or VAD model to map emotions.
Biometric data, like my Fitbit feeding into the music AI.
Potentially, yes.
Yeah.
Our analysis mentions biometric data integration, where things like your heart rate, maybe even EEG brainwave data, could directly influence the music being generated in real time. OvaMind's work in gaming, adapting based on body reactions, hints at this kind of possibility.
Whoa, so the music could literally change based on how I'm feeling second to second, or maybe be created specifically to make me feel calm if my heart rate is high.
Exactly. That opens up some fascinating applications. Personalized soundtracks, for instance, music tailored perfectly to your current mood, activity, or needs. Imagine a workout playlist that speeds up when your heart rate drops, or calming music generated specifically for you when you feel stressed.
That sounds amazing.
It could also be huge for mental wellness and therapy. AI creating anxiety-reducing soundscapes based on your real-time physiological data, or recommending specific generated pieces based on your expressed emotional state.
Music therapy supercharged by AI.
Potentially.
Yeah.
And for content creators, think adaptive media. Music in a video game or film that dynamically shifts its emotional tone intensity, mood to perfectly match the action or dialogue happening on screen, generated on the fly.
That would be incredible for immersion.
It offers powerful creative collaboration tools for musicians. AI assisting with generating melodies, harmonies, chord progressions, maybe even suggesting lyrics that fit a certain emotional vibe.
So AI as a creative partner. The future impact on artistic expression, making music creation more accessible, it sounds really exciting. And the therapeutic applications are intriguing too.
Absolutely. It could unlock totally new forms of musical expression, empower non-musicians to create, and offer unique therapeutic benefits. It might also shift the economics of music creation.
The challenges must be significant here too. Authorship.
Huge ones. Authorship and ownership are massive question marks. If an AI generates a hit song, who owns the copyright? The user who prompted it. The AI developer.
Right. And what about plagiarism or mimicry? Can AI generate music that sounds too much like an existing artist?
A major concern. Deepfake voices are another issue, generating vocals that sound exactly like a famous singer without their permission. Data security for any biometric data used is critical, and inevitably concerns about job displacement for human musicians and composers.
And how accurately can AI even map subjective emotions to music? Isn't that deeply personal?
That's a fundamental challenge. Mapping something as complex and subjective as human emotion onto musical features is incredibly difficult and potentially fraught with bias or oversimplification. It positions AI as this emotionally intelligent creative partner, but it definitely raises a crisis of authorship and authenticity in AI art.
So much potential, so many complex issues. Now, looking at all 5 of these advancements together, the AR, the gaming, the 3D creation, the learning assistant, the music, what are some of the big picture connections you see emerging from the analysis?
Well, several key themes. Definitely weave through all of them. Multimodal AI is clearly a foundational enabler across the board. It's that ability to understand text, images, audio, video, sensor data all together that powers so much of this.
Right, it's the input.
Then generative AI is the engine driving the creation of new content, whether it's AR overlays, game narratives, 3D assets, learning exercises, or musical pieces.
The output engine.
Exactly. AI agents seem to be the way Google envisions orchestrating more complex, proactive assistance across different applications. You mentioned agent space earlier.
The proactive layer.
And personalization is the unifying principle, running through everything, tailoring experiences right down to the individual user based on their data, context, and maybe even emotions.
And Google's core AI models and platforms are what tie all of this together, technically.
Precisely. Models like Gemini, in its various forms, and the open models like Gemma provide the core intelligence, often capable of running directly on devices. Platforms like Agent Space provide the structure for these AI agents. Tools like Notebook LM act as specialized assistants for tasks like research, and Android XR is the delivery platform for the AR vision.
It sounds like they're building this comprehensive layer of intelligence over everything.
That's a good way to put it. Our analysis talks about the emergence of a cognitive computing layer and this accelerated magic cycle of research where breakthroughs feed rapidly into products.
So stepping back even further, what does all of this mean for society and the economy as a whole, beyond the tech itself?
Well, economically, the expectation is significant transformation. AI driving ROI, increasing productivity, creating new markets and revenue streams, but also realistically causing job displacement in some areas.
It's a double-edged sword.
Always. And societally, we're clearly moving towards an increasingly close symbiotic relationship with AI. AI as an assistant, a co-creator, a tutor, enhancing our capabilities in countless ways.
But raising fundamental questions.
Absolutely. Raising questions about over-reliance, the nature of human skill and creativity, and threading through everything, those critical ethical imperatives.
Yeah, the ethical concerns seem to echo across all 5 areas.
They really do. Data privacy, algorithmic bias, potential for misuse deepfakes, manipulation, intellectual property battles, accountability when things go wrong. These aren't side issues, they are central. Google emphasizes responsible AI development, but navigating these challenges in practice is incredibly complex.
So, to bring it all together, we've explored some truly groundbreaking AI advancements from Google hyper-personalized AR, dynamic game stories, instant 3D models, proactive learning partners, and emotionally intelligent music. Each one has the potential to really reshape how we interact with technology and the world around us.
Yeah, it's a lot. From much more immersive digital experiences to deeply personalized learning and completely new forms of creative expression, the landscape of possibilities is just vast.
It's a fascinating time, no doubt about it. And these developments really give you a sense of just how rapidly AI is evolving and the profound impact it will likely have on, well, all of our lives.
Absolutely. And maybe as you consider all this, the question to ponder is, how comfortable are you with this level of proactive, personalized, context-aware AI? Where do you see the biggest benefits and where do you draw the line? It's a conversation that's really just beginning for all of us.